My name is Rebecca Chappell and I'm a junior sustainability consultant at Turner & Townsend. And we're joined today by Dan from Turner & Townsend. And this is a retrofit information support and expertise event, which is fully funded by the Department of Energy Security and Net Zero and delivered by Turner & Townsend. I will now hand over to Dan to start today's presentation.
Thank you very much, Rebecca. Yes, and welcome everybody to today's session, a complete beginner's guide to retrofit. The agenda for the session today is quite an overview sort of session. But yeah, we'll start with a little bit of background on retrofit, talking around what is it, what are some of the things that we can use to retrofit as well, how do we measure energy efficiency when we talk about retrofit, some of the key terms, things like that, and then a little look at sort of role responsibilities, kind of linking to your PAS 2035 sort of thing, and then a final word on retrofit strategy. So we're going to sort of touch on a whole bunch of stuff today, but hopefully just gives us that nice overview of the process. So yeah, let's get straight into the background then. So why do we want to retrofit? What's wrong with what's going on at the minute out there? Obviously, we've got quite a lot of food poverty issues, housing crisis, energy crisis, a lot of these sort of big social and economic challenges going on, and then of course there's the decarbonisation element of as well, and the climate crisis. So the way that we're sort of carrying on living our lives and living in our homes, probably we can't continue as we are, and housing touches on all of these things because it's obviously, everybody needs a home, and if you have a poor quality house, it's expensive to heat, expensive to run, it can be harmful for your health in terms of having that home that's too cold, not being able to afford to heat it, and of course if it's really expensive, then that adds an additional financial pressure onto people's lives, and of course the more inefficient a building is, the more fossil fuel has to be burnt to generate the energy to heat that home as well. So there's a lot of problems with the way we run things currently, and retrofit is designed to tackle that. Our homes account for about 23%, I think, of the UK's carbon emissions, and I think a lot of that, the vast majority of those emissions are to do with specifically, the heating of the building. So when we think about, tackling that decarbonisation element, really it's the crux of it is how we decarbonise domestic heating. That's the real crux of the decarbonisation issue. I think some of our housing is pretty much like the oldest and least efficient housing stock in Europe. So you can see that nice little graph on, or well, I say nice, it's not very nice unless you're in Norway, I guess. But yeah, it's showing sort of the, after 5 hours, what the temperature difference is, what the loss of heat is in a home once it's been heated up to temperature. And you can see that the UK there has, on average, got the highest levels of heat loss after 5 hours. So our homes lose heat faster, which is bad because obviously that means we've got to burn more fuel, and that costs money and that costs carbon. So that's a big challenge for us. And why retrofit? Well, I think there's something like 27 million existing homes in the UK. So, do we spend money to knock 27 million homes down and rebuild them? Clearly not, because that would be just so impractical for a whole bunch of reasons that it's not even worth explaining. It should be very obvious. So we have to do something with a lot of these buildings to address this, and that's where retrofit comes in. We can address these issues. So what is housing retrofit? Retrofit is the process of making changes to existing buildings to reduce energy consumption and associated emissions. That's all it is. We are simply going back in and we're adding bits, editing the building fabric or the building systems to make them better, to address those sorts of challenges. And of course, then the point of this is that you end up with these things on the left: the affordable bills, the increased comfort, better regulatory compliance. We're thinking about decent homes and the minimum standards, etc., that we want for our homes. The lower emissions, obviously, reduced health risks, instead of where we are now currently, which is a lot of fuel poverty, a lot of cold and damp, and the increased health risks that come from that, a lot of wasted energy, and a lot of just unsafe poor quality housing, really. So retrofit's very much part of this sort of holistic treatment of improving a number of problems that are all quite interlinked regarding health and climate change. So what are some of the options available to us? What are some of the things in our toolbox? We've got a lot of things that we can do to properties. I won't go through everything on the slide here, but you can get a good flavour of what's sort of available. Yeah, so retrofit options, lots of things available to us. The main category that people think of is insulation. So that's predominantly your big three: CWI, EWI, and IWI. So your cavity wall insulation, your external wall insulation, and your internal wall insulation. Also, loft insulation in there as well. Various forms of roof insulation. You've got things like the microgeneration and renewables. So that's your kind of air source or ground source heat pumps, solar panels, things like that. Probably not a lot of micro wind generation, I guess, unless you're on a farm, probably. Or is it David Cameron that wanted to put a windmill on his house back in the day? But yeah, there's a whole bunch of things you can do in that kind of category. Heating, so that could be high retention storage heaters, heating controls, various sort of bits and bobs you can do with that. Better windows, better doors, lower energy lighting. Yeah, ventilation as well, another very, very important category when it comes to retrofit, which I think we will talk about in some of the later slides as well. So what do some of these look like? That's some underfloor insulation being laid down, probably on a suspended floor, I would imagine, with that kind of setup and that bay window. There's an air source heat pump there in the top, in the middle. Important to note as well that with that air source heat pump, that's the kind of external bit that is always in all the photographs. There's also a large hot water tank, which you need to find a space for, which in some homes isn't a problem because there might already be a gas boiler with a hot water tank in a property, but not every property that will be retrofitted with an air source heat pump might have that sort of system, particularly if it's a combi boiler thing in there. And so, it's always worth remembering that, finding space for that large hot water tank on the right there. I like that illustration as well because it gives you a good impression of the kind of way that it has to be installed, all these different layers that kind of work together to insulate and weatherproof the home. And that's why it can only be installed in certain conditions, because you have to leave time for things to set and cure and everything, and that can only happen in certain temperature ranges. The bottom two there, the glazing and the PV, I think it's quite obvious what they are. Ventilation, that's a sort of bit of mechanical ventilation with heat recovery system. Tend to get MVHR more on new builds or very sort of high level retrofits where you're dealing with a lot of air tightness, but it's not the only sort of ventilation system out there. And a really important part of retrofit is the ventilation strategy, because it impacts so greatly the damp and mold, the humidity, and therefore the health sort of outcomes for the property, as well as preventing sort of damage to the fabric of the building from excess moisture. So yeah, always important to remember your ventilation strategy, and it's a key part of PAS 2035. So how do we measure energy efficiency? There's sort of primary method that we use is the EPC, the Energy Performance Certificate, and this is a sort of a 2-3 page certificate that's basically generated by something called the Standard Assessment Procedure, so SAP, which is a sort of a mathematical modeling methodology, which sort of creates a mathematical model of the house based on some sort of inputs and assumptions that an assessor will go around and collect that information for, punch the numbers into this big spreadsheet, and then out pops a rating for your house. And there's sort of various iterations of SAP over the years, and we've got SAP 10 coming in, I forget the date, very soon, confirmed for real. It has been sort of the kind of nuclear fusion of energy efficiency and retrofit, I guess, in that it was always coming next year, but it never seemed to arrive, but it is coming for real this time, apparently. There's also RDSAP and FSAP. So when you typically do new build stuff, you will be doing a full SAP and FSAP survey, FSAP generated EPC, because you'll know exactly what materials and the specifications for the, those materials are, how quickly they lose heat and things like that. So you can be more precise. You don't have to make as many assumptions. when we're working in retrofit, what we tend to find is we're using RDSAP, reduced data SAP, to generate those EPCs. So they're based on a lot more assumptions about how efficient a wall is at stopping heat, escaping, for example. Because, I mean, what are you going to do? Like get the builder from the 1930s to come along and tell you the U value for the exact cavity wall that they built? I think not. So that is one of the kind of dangers, I guess, of in retrofit with this kind of methodology, is that we have to make a lot of assumptions, and that can lead to performance gaps between what we model and what we expect and what we actually achieve. So that's a whole sort of other conundrum, I guess, to unpick. There's also other sort of methodologies out there for measuring energy efficiency. So if you're doing the really high level type of retrofit, you might use PHPP, which is Passive House Planning Package. And that's generally adopted for passive house, or in retrofit, the retrofit equivalent standard for passive house, which is for new builds, is Enefit. So if you're doing something like that, which is normally very low energy building, lots of, very clever stuff, it faces the right way to get the maximum amount of solar gain and releases the heat over the course of the day carefully, and it's all very precise and very airtight building. But yeah, in most cases we'll be using SAP, and certainly within the context of warm homes, that's kind of what we're expecting to see. So you can see here there's a section of the verification sheet which sort of gives you an idea of some of how these kinds of models work. So SAP's kind of similar in that it's got these kind of boxes you fill in with values, and then it's calculating things in the background. And most of our homes in the UK are kind of around this kind of D band sort of level or worse, so maybe 2/3 sort of a D band or lower. And that's of course what these warm homes programs are really designed to try and tackle, trying to get them out of those D, E, Fs and Gs and up towards C and above, with SAP C kind of being that, regarded as that kind of reasonably solid kind of base level for retrofit. As I say, there's a lot of nuance to SAP and EPCs and the inaccuracies and what they favor and stuff in the modeling and the generation of that rating. But yeah, that's a whole other rabbit hole that we don't quite have time to get into right now. So some of the key retrofit terms then that you might come across, two big ones: fabric first and whole house. So your fabric first is just the idea of fabric first retrofit. We're going to reduce the heat demand of the building by improving the building fabric, the structure of the building, so the walls, the roof, the floors, the windows, doors, etc., so that they are very well insulated, nice and airtight, and therefore you're not losing a lot of heat through the structure of the building. That's going to mean that it takes less energy to heat the building to a good temperature because it's holding on to the heat for longer. And only then, once you've got that fabric to a reasonable level, then you look at upgrading, and decarbonising the heating sources, for example, installing an air source heat pump, replacing that gas boiler, and adding solar PV or whatever it is that you want to do. Important to note, it is a principle, not dogma. And I think we've seen this in this kind of the policy of warm homes over the last few years, where it was very, there were explicit space heating demand targets in place, for example, in wave 2.1 of the SHDF. And that has kind of been loosened a little bit. It's not been made as explicit. So even though it's still, a guiding principle, it isn't dogma, and that's really to allow a lot, because there's a lot of nuance to individual buildings and kind of the most efficient way to retrofit them. But as a principle, it's a pretty solid way of ensuring that you don't just decarbonize the heating and then plunge somebody into fuel poverty because you're not addressing the fact that the building is very inefficient and takes a lot of energy to heat, which is therefore expensive, particularly with electricity being more expensive fuel than gas. Whole house as well. So this is the other sort of key retrofit term, is this idea of having a whole house plan. And this is something that's really important that comes through in PADS 2035. This idea of a comprehensive plan for home improvements. So you don't just kind of go, oh, well, we'll add a bit of this and we'll add a bit of that, and we'll kind of make it up as we go along. We'll slap on some insulation here and maybe, I don't know, add this heat pump. You think about the order of the measures that you're going to install and what each one is going to achieve and how that's going to take you towards where you want to be in terms of that space heating demand, the SAP rating of the property, etc. And crucially, making sure that you're installing measures in an order which does not damage or require you to go back and rip things out and put things back in. For example, if you're doing, if you need to do external wall insulation and replace windows, it's kind of good to do them at the same time, because if you come back and do windows afterwards, you might be you're introducing a lot of technical risk there in terms of breaching seals and stuff around the EWI, and it could get quite messy and invalidating warranties, all sorts of things that we don't really want to do ideally. And also it then enables you, as I say, it's sort of hinted at with that fabric first idea of not putting people into fuel poverty by just decarbonising heating. It lets you plan for that in an appropriate way. It's all about thinking about the building as a integrated system rather than sort of individual elements, which is sort of a bit of a downfall possibly of various schemes sort of over the last 20 years before the introduction of PAS 2035, which we'll get onto in a bit. Other key retrofit terms, we've got things like air infiltration. So this is, basically like, imagine you've got an ill-fitting old front door and you can kind of feel the draft coming in underneath it. There's a crack around a window or something like that. It's just air flows through gaps in the building fabric that is unintended. Different to ventilation in the sense that ventilation we want to be able to control. This is almost like unintended ventilation. It's not intended. We're not in control of it. It's just happening. And we don't want that. We want to be able to control the air which is coming in and out of the building, because then we can make it most efficient and not lose loads of heat while doing so. Thermal bypass is quite similar as well so this refers to when air is sort of moves through or around insulation, so effectively sort of bypassing it. So if there's kind of like a gap, I think there's a good example of this. You can find diagrams within of like a cross section of cavity wall and how you can get sort of convection currents going up in the cavity if there's an air gap in there, which sort of takes heat sort of from the lower part of the wall and takes it up towards the top, and that creates cold spots and on the wall and things like that. It's a little bit more complicated to kind of get your head around thermal bypass, but that it's I recommend looking at some diagrams for that one. But it's basically just this idea that air movement is going to start shunting heat around, and sort of move it to places that you don't want it to go by bypassing those insulation measures and things like that. And then everyone's favorite, thermal bridging or cold bridging. This is just an area of a building that has a higher level of thermal transmittance than surrounding materials, so therefore it's colder because more heat is able to escape through it. You often find these sort of junctions between building materials, so where joists meet walls, windows meet walls. You can kind of get a really good impression of it in this sort of picture here on the slide. You can see the windows there obviously have a higher level of thermal transmittance than the walls, and you can see sort of the upright timbers there, I guess, in this wall that have a higher level of thermal transmittance than the stuff either side of it, which is probably insulation packed in there, I'd guess, in some sort of timber frame. So yeah, those areas where there's more heat escaping and therefore it's colder, and that can then cause problems with damp and condensation, because obviously that's where water vapor is going to condense. So that can often have a big impact on mold growth and sort of water damage to building fabric. Roles and responsibilities then. So this is kind of, I keep talking about PAS 2035, and this is kind of that bit. Wes has asked, small measures such as draft excluders or radiator retrofit considered retrofit? Yes, they are. So you can find, for example, in SAP modeling, draft proofing as a measure. It's kind of more like like installing LED light bulbs or something that is obviously it's moving the needle only a little bit. It's not like a big expensive measure, but it is it's all part of this kind of retrofit strategy. I suppose. What happens when it goes wrong? retrofit, this is why we have PAS. So there's some examples here of what happens. So there's an example of 300 homes that were rendered damp and uninhabitable due to poor quality design and installation of EWI. So you can see there that what's happened. Well, it's only one photo. I can't get the full diagnosis, but clearly what's happened is the EWI has been installed improperly, and there's obviously been water that's either come down the back of it, maybe it's not been capped off properly, or the roof line not extended, and that wall has got damp. And then you're seeing a lot of clear water damage that's, as that wall has become saturated with water. There's probably some fungus growing on there and all sorts of nasty stuff. Defective CWI can cause sort of similar issues as well, because if it gets waterlogged, so maybe you've installed it inappropriately in a cavity that's too narrow, or has it's a very exposed elevation, maybe exposed to a lot of driving rain. The brick has got saturated with moisture. That's then got into the cavity wall insulation, or wool or something, rock wool maybe, and then it's just like being covered in a damp tea towel, which is really not good at all, obviously, and then causes a lot of damp and mold problems. A lot of cowboy installers of CWI back in the day, so that it's quite a common thing to find a defective CWI. But also, you can also get things like where it's not been installed properly, and it's really patchy inside the wall, and then you get lots of cold spots because some bits of the wall are warm, others there's no insulation. So then you'll get cold spots on the wall, which encourages all the moisture in the property to land on that bit of wall, and then therefore you get damp and mold. And then another example there of another 104 homes that were rendered damp and uninhabitable due to EWI. So it all comes down to water, basically. water. That's why it goes wrong, basically, moisture in buildings. So how do we ensure quality then to kind of prevent that from happening? We need good tenant protection, so retrofits have to meet tenants' needs, and there needs to be a mechanism in place to report issues to landlords and things like that, or whoever owns the property. It needs to be advice and guidance, so they need to have access to impartial advice that provides comprehensive information about existing and future measures. So what have you put in the property now? What are you going to do in the future? How should you use it? That kind of thing sort of links into that sort of skills and training, I guess, as well, making sure that people know what they're doing, both people living in the property knowing how to operate, for example, their air source heat pump, and get it working, but also, of course, ensuring that the people installing it sort of aren't chancers and charlatans, and actually know what they're doing, and are capable of doing really good installs to prevent shoddy work from sort of being signed off and then leading to problems in the future. We also have a lot of robust standards, so PAS 2035 and Trustmark, for example, that require things to be done in certain ways. And there are various checks and things like that in place to pick up on quality issues, and then compliance and enforcement. So that's probably the most important of all. There's no point having all these standards and protections and things like that if you don't have somebody to kind of ensure that they're actually being followed. So that's a very important thing. So finally, 25 slides in, we get to PAS 2035. What is it? It stands for Publicly Available Specification, and there's a whole bunch of PASs out there. I don't know what most of them are, but these two, PAS 2030 and 2035, are probably the ones that you will hear in Retrofit quite a lot. It was sort of first published, PAS 2035, in, I think, 2019, and there's just been a revised, although that version has now been sort of phased out. And there is a revised version that was published in 2023, and that's now the sort of the most up-to-date and current one. And it basically outlines a process for how retrofit projects should be managed and delivered. So it requires certain people to come in at different stages, and we'll have a little look, I think, possibly on the next slide about what that looks like. But it's just it's a standard that covers how when you should install, when you should commission, how you would plan for this, assess things, evaluate, all the rest of it. PAS 2030 is quite specifically about the actual on-site installation of stuff. So that's more like for your installers. to be PAS 2030 accredited, showing that they can sort of install technical things to that standard, which is it's kind of like Russian doll. It's like nested within PAS 2035. You do your PAS 2035 process, you get to the PAS 2030 bit, and you carry on with PAS 2035. So yeah, the sort of guiding principle of PAS 2035 is that whole house comprehensive approach. So it's all about treating the building as a system of elements, interfaces, and occupants as well, which is crucial because not everybody lives in their house in the same way. So people are going to be generating different amounts of moisture, for example, depending on how much cooking or cleaning or like showering they're doing in a house. Big house full of lots of people probably got more moisture generation going on, for example. And not as a set of elements that are independent of each other, which again is kind of previous had led to some of the sort of gold rush cowboy jobs that led to things like the Fishwick sort of disaster in Preston, where you had hundreds of EWI jobs done on homes. They were done really poorly without any sort of proper thought for the moisture management, basically, and it just destroyed the fabric of loads of buildings. And it was quite a scandal, especially when the company then went out of business and disappeared. And they're still kind of spending money, still kind of cleaning up the after effects of that. The NEA has done a lot of work with that particular scheme to repair things. So I'd really recommend looking into that if you're new to retrofit. But that sort of prompted this Decent Homes review, it was called, which sort of reviewed the disaster and effectively then led to the creation of PAS 2035. So it's very much born out of this kind of very destructive, lazy kind of retrofit that we've had in the past. So this is the PAS 2035 framework for delivery, and it must be followed for a retrofit project to be compliant with PAS 2035. If you've got a detailed delivery plan, hopefully this will be delivered very smoothly and successfully. The whole point of this is to sort of help control timescales, budgets, and manage expectations with internal and external stakeholders, so what's happening when. Hopefully then you can make better plans when it comes to costing and things like that. So yeah, there are other things sort of outside of this that you would probably want to consider. So when you're reviewing your housing stock and other asset data, for example, to pull your project together. But sort of officially, this is when you get into the PAS process proper for a home. This is where we go. So you sort of come up with the project. You'll have a retrofit coordinator who is the person who oversees the entire process. So you've always got somebody with some oversight and who knows the full story. You'll then have assessors sort of coming in and carrying out various assessments. So there's a retrofit assessment, which is kind of like a super EPC, basically, that they'll do, which is an EPC but more detailed. And there'll be a dwelling assessment as well. So within that, there will also be a ventilation assessment, because it's such an important part of the strategy to prevent those kinds of issues we saw on that slide previously. And then from this, the coordinator will then come up with sort of an improvement option evaluation. And so they will look at the options available and try and create this medium-term plan, this MTIP, a medium-term improvement plan, which sort of details what measures should be installed and in what order, that kind of thing. You'll then have a designer that comes in and sort of designs the actual sort of specifications for these things to meet the specifications that they need to achieve whatever the retrofit needs to achieve. And then you get an installer in to do it, and that's the big blue box there, which is the PAS 2030 bit, basically, which sort of follows installation and testing, commissioning, and handover. And then you're kind of back into PAS 2035 for monitoring and evaluation and sort of handover advice to the occupant as well. So you can see it's quite a logical process. Assess, have a look at the options, do the designs, somebody installs them, and then you check that it's doing what it said on the tin. That's basically what all PAS is doing. It's just making sure that you're not forgetting anything that could be very crucial. So these are some of the roles. So you'll see things like the coordinator is probably the most important one. Assessors, so people that are conducting that kind of super EPC at the start. Designer and the installer. Those are probably the most important ones there. The coordinator, a lot of people like to have a separate the coordinator be quite separate from their assessors, designers, and installers. So often people will get a turnkey in, for example, a contractor who will install things, and people who are installers tend to also like to be designers as well, because they don't like following other people's designs for kind of various reasons. So a lot of the time that kind of assessor, designer, installer stuff is all kind of packaged up in terms of, you know, how it's offered as a service, and that's fine. You can also then get turnkeys, for example, to do coordination as well. But a lot of people like to keep the coordinator separate, because it's sort of, there's this feeling of, well, I don't want my contractor marking their own homework. Do you know what I mean? So quite often, you know, if you're worried about that kind of thing, you can then sort of get a different coordinator in from someone, separate company or whatever, or a separate freelancer to come in and do that kind of role to ensure that separation, and then, you know, ensure there's better oversight, basically. And the fact that these roles are all split out like this kind of enables you to do things like that. As long as those roles are fulfilled, you can get you past 2035 accreditation. So I briefly mentioned some of the retrofit standards earlier. I think I talked about a little bit about Retrofit, which is the passive house equivalent for existing buildings. So this is, yeah, really high level quality retrofit. In my head, I think of it as a bit more grand designsy rather than kind of sort of, you know, at scale. But it's all about, yeah, increasing the levels of insulation, minimal thermal bridging, and a lot of ventilation with added heat recovery systems to, yeah, make things as efficient as possible. There's also other retrofit standards out there, though, like Letty do one, and there's also, yeah, I forget the name. There's a whole bunch of sort of different approaches, basically, zero carbon homes, things like that, that sort of specify minimum performance standards and targets for things. So you can always sort of choose what, you know, how far you want to take your retrofit. Normally the question is basically, how far should I improve the fabric of the building to take me to a position where I can then decarbonize the heating without putting someone in fuel poverty. That's kind of basically the big tension in retrofit, because obviously you want to get, you know, the home to a point where you can then run that heat pump or something as efficiently as, you know, well, at a level at which it is not adding to the cost of running the home. And if you do that, then you're obviously saving money compared to taking it further. And if you save the money, you can put that money towards retrofitting another home. So it's just a bit of, you know, classic sort of, where do you set that bar? You know, do you go all in on a smaller number of homes, or are you looking to kind of get it to that you know, that acceptable standards that then you can treat more homes at scale? And increasingly, personally, I sort of see out there in the sector, I think, you know, much more of a move towards trying to get to something probably around 90 kilowatt hours per meter squared per year space heating demand, which tends to be about the level that you can, you know, run a heat pump, an air source heat pump, without worsening fuel bills. And then sort of, yeah, once you've got the fabric to that point, then decarbonising heating, that it seems to be sort of the way things are moving, at least from where I'm standing. But that's not to say that that's the best or the only route. These other standards are definitely worth exploring for other reasons as well. So certification and accreditation. So the other things you'll see on the warm homes that mentioned Trustmark. So this is the only government endorsed quality scheme for retrofit in the UK. Covers all sort of home improvements, and it sort of in the context of warm homes, really what it means is that installers, and when they've installed a measure, they'll be required to sort of take lots of before and after pictures and upload sort of documents which show like the specification for the thing that was installed, warranty, that kind of thing. And they send all this information off to Trustmark, who store it all. They give it a number and they store it all in this big data warehouse. That means then that there's a trail of accountability, so that if there's ever an issue with that property and a particular measure or set of measures associated with that property, there's a paper trail. You can see who installed it, when they installed it, what was supposed to happen, you know, that kind of thing. So it's, yeah, it links in quite strongly as well with that PAS 2035 process in terms of the accountability and the proper handover of things. There's also MCS, so that you'll see mentioned, so the Micro Generation Certificate Scheme. This is kind of like the PAS 2030, but for air source heat pumps and solar PV, basically. So this is a contractor certification scheme for low carbon and renewable heating and other renewable technologies. So yeah, heat pumps, solar thermal, PV, batteries being probably, I think, something that more and more people are becoming interested in, because under SAP 10 you can model with batteries. So there's going to be the prospect then, therefore, of those being easier to claim grant funding for probably in the future, which previously hasn't been an option because you haven't been able to model them under the sort of existing versions of SAP that people have been using. MCS sort of ensures that everything's safe and installed to a good standard by somebody who knows what they're doing, basically, much in the same way that PAS 2030 does the similar sort of thing for people installing loft insulation or something like that. So I think this is the very last slide before we kind of go on to just, wrapping things up and questions. So retrofit strategy. So when you are thinking about your strategy as an organization, how do you go about doing that? And this is probably mostly from a sort of warm homes social housing fund perspective, but there are definitely principles here you can take for private tenure retrofit as well. Although, of course, because you don't own the stock there, things are a little bit different. But essentially, there's a whole lot of preparation in a retrofit strategy, and then kind of delivery feels like, almost when you get there, it feels like, oh, now we've just got to deliver it. This feels so easy in comparison. Of course, it might not be, but that's a whole other kettle of fish. So the preparation stage, that's going to involve gaining senior level buy-in, possibly forming a consortium if you're working with partners, particularly for a funding bid like SHF, and creating that team. Data collection and analysis, very, very important to understand the quality of the data you're working with. Understanding your homes, yes. What you need to do, develop the retrofit interventions for them and do the modeling. But, you need to be aware of the limitations of that for sure. Otherwise, you can end up basing some decisions, fundamental bid decisions, for example, information which turns out to be completely inaccurate. And that will then seriously undermine your ability to manage your project effectively when it comes to actually installing. We see that all the time in retrofit. Planning resident engagement, absolutely vital. When we're doing a 100 home project, for example, we're not just doing building a bridge where we're just building a bridge and, you've got one big goal in mind. With 100 home projects, you've got 100 mini retrofit projects, and there's somebody living in the middle of your building site, and they might have, I don't know, a baby on the way, or a cousin from Australia coming to stay for 3 months, or end of life care, or they've got their own lives going on in the middle of your building site, and you have to kind of be prepared to deal with everything that comes with that, people and their lives. So it's very important that is planned early on, what your systems are going to be for engaging people, being, who's going to be points of contact, when are you going to check in with people, all those kinds of things. Building the business case, obviously you've got to get that senior level buy-in, but then, when you've hopefully got a bit of a nod to go for things, there needs to be a bit of a business case behind it as well. You've got procurement to look at, and how do you're going to do any sort of social value or sustainable procurement type stuff. Maybe your organization has policies for that as well. Planning constraints need to be looked at. So quite often people will be, particularly I think in a, private sector, Warm Homes Local Grant, for example, you tend to get a lot of conservation area or, listed building type of things going on. And that can be a whole, challenge in and of itself. There's some really interesting things to look at there in terms of case studies around how people are able to kind of get around that. We've got some really good resources on the RISE website as well about that. I think a masterclass on planning and heritage properties, a lot of stuff talking about local listed building consent orders and Article 4 directives and various other bits and bobs, to get PV and double glazing sash windows in. But that's definitely something that is worth looking at before it comes back to haunt you. Understanding PAS 2035, so that's how, a big part of if you're going to be doing, again, SHF or LG. You need to understand that because it's a key part of how you're going to be required to manage the project. And if you understand it, at least at a, theoretical level, you understand the process and things, it makes managing your contractor a lot easier because it's harder for them to sort of pull the wool over your eyes, if bend the truth a little bit, if things aren't quite going as planned. Your monitoring and evaluation strategy, absolutely essential to understand, is what we've done actually working? Because if it isn't working, why the hell would we do that again? We need to change that. So really important, particularly again, when I talk about those inaccuracies in data and modeling that we tend to find in retrofit, performance gaps, understanding that is really important because ultimately we don't want to let people down by installing something that, isn't what we hoped for. And we don't want to spend our money, base financial decisions on things that have inflated or overinflated outcomes. So very important that we look at that. And then finally, delivery, we're there. So that's when we do the whole building assessment, do all our surveys, detailed design, detailed delivery plan, and install it, which feels quite simple to say, but of course is quite challenging in its own right. And then once that delivery is completed, it's absolutely vitally important that there is a proper handover to residents and that you've thought about maintenance for these things, as well as that ongoing M&E. So do people know how to use the new heat pumps? Do your maintenance teams know how to sort of service them? Are they qualified to do that? There's all of these sorts of questions that need sort of answering in the post-retrofit stage as well. The Retrofit Academy, another great resource if you're interested in learning more about PAS 2035 and BSI as well. I think you can find the actual standards there to download as well. So yeah, I think PAS 2035 is a free PDF download. Other resources, plenty more resources, as I say, on the website. You can click on more of them there. We've got podcasts, masterclass, knowledge hubs, articles, various bits and bobs that you can all find on there. And the last plug is a plea for anybody that hasn't already booked in their mobilization confidence assessment, the MCA meeting with your RISE DSM. Please do so. You can just contact the RISE at turntown.co.uk, email about that. To book that in for that kind of one-to-one chat about your project, what the potential barriers to successful delivery might be, how you can receive some more support to try and tackle that stuff, and hopefully get yourself off to the best possible start. So thank you very much